A machine component is undergoing simple harmonic motion with a frequency of 4 Hz and an amplitude of 5 centimeters. Plot a position versus time graph with the intervals being 0.125 seconds for 3 periods. Okay, so if we look at this, we have to figure out, we have 4 Hz, so that would be the frequency, which is 4 cycles per second. So we know the frequency here is 4 Hz or 4 cycles per second. And to get the time per cycle, if the frequency is 4 cycles per second, the period would be the inverse of the frequency. So this is 1 over 4 Hertz, which means this would be 0.25 seconds. Okay, so 0.25 seconds would tell you the time per period here. So if we start at 5, we're going to end up back at 5 in 0.25 seconds. And then we'll end up again at half a second, 0.25 seconds later, at 5 centimeters. And then for the third period, 0.75, which means halfway in between, we would be at -5. So the graph would look like a cosine function, and it is going to oscillate back and forth between +5 centimeters and -5 centimeters. Okay, how long does it take to go from -5 to 0 centimeters? So if we look at -5, we're essentially looking here to 0 centimeters. Now if we look at this whole cycle, this part of the cycle represents a quarter of the cycle. And break the cycle down into 4 parts. You got the first quarter, second quarter, third quarter, fourth quarter. This part here would be the time. So it would be a quarter of the period. So if we know the period is 0.25 seconds, it would take 1/4 that time. So divide the period by 4, and that will equal 0.0625 seconds. Okay, for part C, they're asking us to write the position as a function of time for what is given. Now, if we looked at the expression derived in class today, this is the amplitude times cosine times 2 pi times the frequency times the time, or A cosine 2 pi divided by the period times the time. Okay, so in either case, we'll kind of walk through this. Either expression will be correct. So we know that this is 5 centimeters, so 0.05 meters times cosine of 2 pi. So this is going to be 2 times pi times 4 Hertz, okay, times t. And that will also equal 0.05 cosine 2 pi divided by 0.25 seconds times t. Either way, both of these will equal the following: 0.05 meters times cosine of 8 pi times t. Now, if we look at all these expressions, they all represent the same answer. Okay, so it doesn't matter whether you represent it like this, or like this, or like this. They're all essentially the same expression representing the position as a function of time. All right, part D. That's to determine the maximum speed and the maximum acceleration. So we'll go to our maximum speed and maximum acceleration equations. We have A times omega, and then maximum acceleration would be A times omega squared. So for the maximum velocity, okay, we have A, which is 0.05 meters, times 2 pi times 4 Hertz. Okay, if we substitute all of this in, what we get out is we get 1.26 meters per second. Okay, and that would be the maximum speed. To determine the maximum acceleration, okay, you're going to have 0.05 meters times 2 pi times 4 hertz. And the 2 pi 4 hertz has to be a squared term. When you solve this for the acceleration, you are going to get 31.6 meters per second per second. All right, so in this problem, we kind of looked at this graphically. We looked at what the graph means in terms of the period, how much of a period it is in part B. In C, we looked at just how to express position as a function of time for an object that is oscillating. And in part D, we just looked at the maximum velocity and acceleration.